Yeah, I have started the recording. Fine. Thank you.
Yes, sir.
Thank you. Thank you for letting me know. Yeah. So as we had discussed last time, right? For any kind of the file acquisition activities or creating a new file or bringing a file from the secondary source or import a file, you have to go through this file menu. But largely today we will be dealing with this Statistica own example data file for the purpose of ANOVA, right? If I wanted to carry out the ANOVA without the taking of anyone help, right? Or what we say the self-paced learning or what are the resources are available within the Statistica to support my learning. So I can go to the help and support, right? Under the help and support, I can expand this help. Under the help, the topic of my interest currently is the ANOVA, right? So we wanted to get into some of the ANOVA example for a better or deeper understanding about ANOVA. So I can go to the Statistica example. If I expand that, right? So there is a wide range of the topics are displayed, but currently my interest is ANOVA, right? So ANOVA I get in Statistica example in the two way. If I go to the basic statistics and table, under the basic statistics and table, the example 2 consists of breakdown one-way ANOVA. If I expand this breakdown one-way ANOVA, right? So they are talking a data set called add study dot star, right? And all the step-by-step instructions are given how to carry out a ANOVA, the one-way ANOVA, using the data set called add study dot star, right? Just we wanted to get a structure of the data set, like in order to perform, that is one of the biggest challenge for the beginners. What should be the data set structure in order to perform any specific analysis? What comes under this? Your data preparation, right? You need to deal with many challenges. I'm not getting into that, right? Just to get a sense of how the structure of a ANOVA data set should look like, or how it should be structured, as one of the data set has been suggested by the Statistica called add study. So I want to file, open example, data set. Currently, I wanted to explore the add study dot star. Add, if I write 2 letters or 3 letters, all the list of the data set begins with that letter, it listed. So I wanted to get into the add study. You can view my screen. You can view my screen.
Yes, sir.
Okay. So what is the volume of the data set? You can, if you can let me know. What is the volume of the data set?
Sir, how to define the volume?
No, because you see a matrix like a table, right? So volume means basically how many rows are there, how many columns are there.
Yes, sir,
Right?
around 12, there is 12 columns.
said, you are making out of this thing because I explained there are more columns, right?
Yes.
You cannot do this. Is not a good practice, right? Suppose you are dealing with 1,000 of variable, you need to scroll it down as typically you do in Excel, right? So in Statistica, we have a better way. Suppose I see on the top of the screen, you view my pointer, there the data volume has been displayed. The data set consists of the 25 variable. The V denotes to column. So I do have 25 columns in this data set and 50 C. The C denotes to my observation or the cases. So I do have the 50 rows and
25 columns.
25 column. What is your primary observation? Although it's too fast, but what you can make it out, like suppose you wanted to do a ANOVA, right?
We have
What
to do
is-
factorial ANOVA.
Why the
I want to do ANOVA
factorial?
because the rows and columns are different.
No, what is the primary your investigation? What this data is all about? What, like suppose you receive the data, although it's very, I'm expecting too much from as a beginner, but like just a quick get a sense to develop an analytical bent of mind. You have received this data, right? So what immediately the problem statement comes to your mind from this data? I do have a gender as a column, male, Pepsi, right? And I have administered this measure 1, measure 2, measure 3, measure 4, measure 5. These are somewhere around 23 questionnaire has been administered or has been distributed between the gender male and female. And there is a studies going on in order to get a preference on the soft drinks, or like, is there any, like, to get a sense of the preference of the soft drinks among the gender. Did you receive the problem statement?
Yes, sir.
So
Yes,
what would be my null hypothesis in this case? Because ANOVA, t-test, parametric, chi-square test, these all are basically an approach for hypothesis testing. Depending on the data, we classify whether it is a parametric test or it is a non-parametric test, right? But these all are the activities of the hypothesis testing. Either I apply a one-way ANOVA, either I apply a t-test, either I apply a factorial ANOVA, irrespective of the activities I do, right? So this is a hypothesis testing, or I construct a hypothesis to test. This is for any kind of your experimental research. So in this situation, what would be my null hypothesis? What is my hypothesis in this case?
So whether the advertisement has effect on the gender.
Yes. Is there any biasness, right?
Mm-hmm.
So what would, like, whether like I have some kind of right? So is there any bias on Coke or Pepsi preferred by specific gender or something like this, right? That we wanted to test, right? We wanted to generate some of the evidence to suggest or to accept that biasness or that hypothesis, or we have to reject that hypothesis, right? So in this case, what would be my null hypothesis?
Whether there is a biasness present.
There is no biasness present.
Yeah, always the null hypothesis consists of the boring hypothesis or the monk hypothesis. So there is no relation, right? There is no connection about this preference on this thing. So that is the situation in every the type of this thing that remains same. right? That we wanted to challenge. So here I go, and as I was talking about, suppose I wanted to do this ANOVA. Hello, right? So under the basic statistics, yeah, under the basic statistics, just you follow this. Under the basic statistics, I have something called breakdown one-way ANOVA. The breakdown, since I will show you why it is known as the breakdown. So I go to the breakdown one-way ANOVA, right? So as usual, I wanted to choose the variable of my interest. Which of the variables I have to deal with? Go to the variables. Under the variables, right, I can pick as many as I want. What do you mean by the dependent variable? See,
Actually, dependent variable is the data which is dependent on the independent factors, the independent ones.
now what is a simple, in general, the meaning of the dependent variable? Because suppose you just mind it, many of the occasion, right? Statistica applies in a very intelligent way. Here you see the so appropriate variable only, right? So this has been checkbox. So that is the reason it has been classified between the dependent and the grouping variable. Suppose I will uncheck that. Many of the occasion you must be doing, or you, since you are a beginner, right? You many of the occasion you may be by mistake or this thing, you may not be clicking this checkbox called so appropriate variable only. So please make sure in most of the analysis you checkbox this so appropriate variable, so that will make your life much more easier. And dependent is nothing, that is your target variable, response variable, right?
Yes, sir.
So just I'm picking up some of this 1 to 9 and grouping, right? I can take, but I'm taking both this thing. Okay. So I'm clicking all this thing, because see, in one this thing you get everything. A summary table of means, detail of two-way tables. So what is the message for you in this process? Whenever you are using Statistica for any analysis, right? T-test, ANOVA, any of the analysis you are doing from basic to the advanced, always please expand there is the tab you experience the advanced tab. So always you expand that advanced rate. I get a postdoc test like lab and test, right? So just I'm going into all this by selection, and so what do you get? Make it out from this ANOVA table, because only out of this 22 questionnaire, just I picked up 9 questionnaire, right? So what you can make it out from this ANOVA table?
The value of measured 7 is significant.
Yeah, the measure 7 out of this questionnaire 1 to 9, right? This measure 7 plays a important role, or this is one of the appropriate questionnaire to study our hypothesis, right, about this biasness, right? So you get all these things, right? Since we right, you get a overview of the two-way table. There also you can make it out how many male, how many female, right? So all these things you can get it out. But just the purpose of showing this data set, right? To get a sense of the structure of the data you should have in order to carry out an ANOVA, right? So let's go to the other part, right? So in order to for your self-learning or for your self-practice, right? You can go to this basic statistics. First, you can go to the help.
Sir,
Right?
I have a question.
Yeah.
In the previous class, we have that when more than two groups in one variable, we need to do the ANOVA. And what is the parameter? Actually, how can we choose that whether we do the one-way ANOVA or two-way ANOVA or factorial?
Yeah,
ANOVA?
I'm coming into that. I'm coming into just this purpose of this example is just to get you a sense of the structure of the data set in order to carry out an ANOVA. Now I'm going back to the last example. The last time we had discussed an example about the reds dot star. Am I correct? If you remember, recollect, we had dealt
Yes,
with
sir.
a data set called reds dot star. And that data set consists of how many variables, how many cases are there in this data set?
24.
Yeah, 24 cases are there and 3 variables or 3 columns are there. What was the study is all about?
That the environment and strain are having any effect on errors made by rats or not.
Yeah, it is a part of a very well the clinical trial process. Like you must be like in your department, like biology and all. This is or in pharmaceutical science. If you go there in their this thing lab, you get a clinical trial and they leave the rats in various conditions, right? Like environment, free, restricted. They apply the different the volume of the doses and they see the reaction. What they typically they do, they capture the movement of the rats and they carry out broadly ANOVA to get a sense about the effect. The similar kind of the study are being conducted in this example also, right? In a match, the rates has been released in the two condition, like the environment and the strain, right? And in environment, there are the environment factor, there are 2 levels are there, free and restricted, right? In order to get a sense of all these, typically, whenever you also make your data or use this thing for the analysis, you record the data, right? You record the data. So here in this case, you can take a note of this. The free has been recorded as 1 and the restricted has been recorded as 2, right? If I double click here, there is a new window will open. Under the new window, if I go to the text label, the text label here, I can see the variable specification and that has been decoded to the what numeric value. If I wanted to change or anything, depending on your judgment of your data, you can do this recording best. Like suppose I'm conducting a study about the high, low, medium, right? So I can decode in 101, 102, 103, or any of the value, like whichever you feel comfortable for your understanding, you can do so, right? The similarly from the strain also, you double click under the variable, you go to the text label, right? The bright has been decoded at 1, next has been decoded in 2, 3. If you wanted to record it in any of the value of your choice, you can do that. And this is the variable description. The 1 denotes to the bright reds, 2 denotes to the average reds, right? 3 denotes to the dull reds. That also for the long variable you can describe under the description column, right? So now coming to your question, sir, how do I determine? I have the 2 factors now, environment and the strain, right? In environment, I have under the environment factor, I have 2 levels, free, restricted. And under the strain factor, I have 3 levels, bright, mixed, and the dull, right? So out of this thing, which one qualify for a one-way ANOVA? Question to you, the participants.
If only the environmental condition and errors are compared, then we can see from one way ANOVA the difference between them, the significant differences between them.
No, we wanted to perform an ANOVA, one-way ANOVA, right? So out of these 2 factors, environment and the strain, one factor is qualified to perform an ANOVA as a general rule. So
Strain.
out of
Strain, sir.
why strain?
Sir, it has 3 factors.
No, it has 3 levels. One factor is
Yes,
3
3
levels.
levels. 3 levels,
And,
yes, sir.
right. The same things I can get under which test? Suppose I consider the environment, which test I would have applied?
T-test.
Wonderful. Yeah. So now we will be doing this one-way ANOVA. Since I have under the factor, I have the 3 levels. So in order to do a one-way t-test, I do have something called under the basic statistics. Under the statistics, I have something called ANOVA. Under the ANOVA, I can perform the 4 type of ANOVA: one-way ANOVA, main effects ANOVA, factorial ANOVA, and repeated measures ANOVA. Fine. So currently, I have a task in hand, one-way ANOVA. Let's go. One-way ANOVA. As usual, I have to choose the variable of my interest. Since it is checkbox, so appropriate variables only. So by default, it is classified the dependent and your independent the variables, or you can say the feature, descriptors, anything, but it remains same. Errors, and I will be taking strain as my independent variable. If I checkbox this, the long name will convert into the numbers, right? So depending on your comfort, right? Or suppose you are dealing with the large number of the variables, right? You can always select by number. So that will zip your long variable into the numbers. Okay. I'll go to the factor code. Okay. Okay. Option. Right. So once you get into right, another thing you can give like the cross validation. Here is the data is very small size of data over 24. Right. Suppose you have very large number of data, maybe 2000, 5000 or 10,000. Always you can do a cross validation. Right. So that is one of the approach to reduce your error or the batch processing kind of thing, right? So let's go with the by default specification. This is what I got, the output, right? Quick, I get this, we'll go one by one for all effects, okay? So this is one of the visual representation. Under this visual representation, we can very well figure it out. What is the name of the graph? What is the name of the graph?
It's a line graph.
This is the mean error plot. Mean error plot. And what the graph, this visualization or this graph suggests, what you can make it out from this graph?
The bright strain are making less errors compared to mixed, and the dull ones are making the most errors.
Wonderful. So this, through this visually also we can investigate a lot of things, right? Then go to the all effects. Under the all effects, we are getting one ANOVA table. So if anyone can interpret the ANOVA table, that would be helpful in best interest of the audience also. Just will rephrase what we had done last time, right? What the SS abbreviates to. SS stands for?
Sum of squares.
Wonderful. What is the degree of freedom? Degree of freedom is nothing but these, because under the factors, we had the 3 levels, right? So 3 minus 1, it is coming, these, the 2, right? And intercept, because the degree of freedom is nothing. So the intercept is basically the beginning point of the line, right? What the MS stands for?
Mean square.
Yeah, mean square. What this app stands for? Where this app value is coming from? If I take this 100,233.4 upon my error 1082.3, right? Just check it out. This is what I get. The app value 100,233.4 or 0.4 divided by my error 1082.3. If anyone do a computation in his or her mobile, that would be helpful in best interest of the audience.
Yes, sir, it's coming to 92.6.
Yeah, the similar kind of the calculation you can do for the second row also, the strain, and what you can make an interpretation from this table or make a conclusion from this table. And this p value is nothing, that is the corresponding value to your app. So what you can do a conclusion from these, the table, the ANOVA table.
The p-value for strain is less than 0.05.
So what is the interpretation?
And the
Data is significant.
Yeah, the variables we are dealing with, or the factors we are dealing with for a study about these, the errors are committing by the reds, we have taken the appropriate variable, right, or appropriate features for this study. The same thing.
So one question,
Yeah.
what is the interpretation for the F value? I did not get that part.
App value, right? The app value is basically the corresponding to the p value. It's the same, right? Right. The app value basically we take in ANOVA the F value, that is the variance, right? By interpretation remains same. If the P value would have been black, more than 0.05, the F value also would have black, right? And the calculation is coming from the F value. Suppose you take the mean square, the column, and this number 100,233, 1,233.40. And if you divide this 1,233.40 to 1082.30, the result will be this 92.61318. This is the computation part for the app, right? But this the app value, largely you can make the interpretation, right? If it is coming red, right, you can make and the correspondingly, like, you do not get a app value without a P value. So whichever the software you use, you broadly get the two are together.
Okay.
So you can make a make an interpretation of the conclusion. The variable we are considering for this study, this is a good variable. In addition to that, let me get something. And what typically, as a researcher, you should more concentrate on these. Can you make out something out of this? Because this is the equation we generated from this. If I go to the report, right, under the report, I get the prediction equation, and under the prediction equation, I get this equation. What I can do with this equation?
I don't know, sir.
And exactly this is where the researcher can do the magic or the wonder. The ANOVA, yeah, we are doing the study to get the basically the relation within and the relation between, right? Relation within means, suppose I do have the two factors, is there any relations between the factors, right? Or is there any relation within the labels? Like in case of the strain, we have the three labels, right? So is there any relations within the labels? Suppose you will be considering more than one factors, then we wanted to have a study on the level of effect on interaction also. Fine. So let's do, like, suppose I do have do you have any idea about any kind of the equation or the modeling or something like this? Do you have any idea about this multiple regression, logistic regression, or you have read in some of the research article or something like this?
Yes, sir, the linear equations, we have a bit of idea.
Okay, linear equation. So this is a linear equation or non-linear equation? Okay, let's do, right? So, but what I would happily recommend, right, you get into the more details. This is one of the area like what a researcher can do wonders, right? Because now you have a tool, and the tool gives you the ability to predict also, right? The prediction means even you anyway will be talking. Okay, let's take this equation, and you just remember this numbers 64.625, or you take a note of this, right? 25 plus, I just take these numbers, Control C, right? In addition to that, as I was talking about, this gives me the ability to predict also. So we have something called PMML. This PMML stands for the Predictive Model Markup Language. So I am taking a PMML code for this. Right? I just right click, and I am taking this, saving this PMML code somewhere in my desktop. ANOVA, I have saved as a ANOVA 2 PMML script in my desktop, right? Let me, why I'm doing all this thing? Because I wanted to predict something. Rosa, just I added some of the new cases here. Add cases. Just I wanted to add 3 cases. How many? I would add the 3 cases. Okay. 3 cases being added. I will be putting some, right? The dull. I have bright, and I have, again, I'm putting just for this bright, right? So I have the now the three different condition, right? I have in one cases I have a condition of the strain, and another 2 cases I have the condition of the bright. So at the moment I can very well predict what would be the error will be consumed under this condition. So how I can do that? There are multiple ways I can do that, but here quickly I go to this data mining. This feature also you have in Statistica currently with you also. Go to the rapid deployment. Under the rapid deployment, you just check variable selection. Oh, sorry. From the disk load, we created a model, right? ANOVA 2 PMML script. Okay. What do you make it out from this spreadsheet? What you can make it out from the spreadsheet?
So using the predictive equation, we are getting the regression model of the 3 data.
We are getting the prediction because the 3 data what we input in the original data set, right? We had the 24 number of cases, right? We added the 3 number of cases. 3 number of cases in this situation, the 3 different situation we gave, right? The dull and the bright, and we wanted to predict how much the error will be committed by the reds. But taking this situation, right? You can predict anything, right? You can predict the yield, you can predict like the any numbers or anything you wanted to predict, the procedures will remain same, right? So we put the three condition, and these are the prediction. Fine.
Yes, sir.
And this is what I would recommend. Even like we had taken this bright dull mix. If I go to again, I go to the text level, I get 1, 2, 3. Am I right? The bright denotes to 1, right? But there may be a situation, it should not be always the constant, right? The bright we have defined 1. So from 0 to 1, there are many the grid, right? The 0 0.1, 0 0.2, 0.3, like 100 grids are there. So I do not know here my objective, how I can create a situation or how I can create the levels which will produce the minimum number of errors will be committed by the rat. So as a researcher, I will be taking all the grid and I will take all the possible combination, keeping my goal in the back of the mind. The less error will be committed by the rats, right? So I can define that whole experience, right? So the similar, like we are done with the one-way ANOVA. So now we go to the two-way ANOVA. Same, go to the statistics, go to the ANOVA, start new. I go to the man effects ANOVA or the two-way ANOVA. Okay. I go to the variable same. Okay. Right. Factor codes has been selected. Option, I'm going with the default one. Fine. Now I'm dealing with the two factors. Here, see, last time I was dealing with the one, I was not getting this under the summary. I was not getting the whole model R, right? So this is very, very one of the important thing for you. Just now we were discussing about the linear regression or the equation, right? Have you come across with these terms like multiple R square, adjusted R square? Have you come across residuals?
No, sir.
Not never. The big R. Okay, what I would heavily recommend, right? Once you go back, and these are the very, very essential. Either you are doing a ANOVA or multiple regression, these are the fundamental of the statistics. At least you should have the primary level of understanding, because either you use Statistica or you use any of the open source like R or Python or any software, either you use SPSS, right? This table may be small or the bigger depending on the feature, right? This code may be somewhere red, somewhere black, somewhere blue, but the table will not differ, and these terms will remain same across the software you use. You do not get a multiple X or multiple something. You get any of the software you use, you get this multiple R only. And this interpretation of the R, this is the basically the big R or small r denotes to the correlation, right? So the correlation between your dependent, the target, the error, and the factors we are considering. Are you getting it? And this is typically one of the assumption we have to qualify. Suppose we are doing a multiple regression, even this thing ANOVA, because the best practice, we should consider the appropriate variables for any kind of the experimental study we perform, right? So there should be a good amount of the correlation between my target or the dependent variable and my independent variable. Please mind it, dependent and the independent variable, my target and the input variable. There are another assumption also, there should not be very strong correlation between your independent variable. Suppose you have these two factors, right? The environment and the strain. There should not be very like the strong correlation, right? 90% or the 80%, there should not be a strong correlation. And in general rule, it should not be more than 80% the correlation between your input variable. Suppose there is a more than 80% correlation between the input variable, you can consider to drop one variable, because you will not having any kind of the information gain if you take both the variable also. Fine. So I would heavily recommend, like you can get into the YouTube or you can get into some of the study materials in order to get an understanding about this linear equation, the R, multiple R square, right? Multiple R square, that is the result of the square of the R, right? And what is the interpretation of this R square is, right? The two variables we have considered, the strain and the two variable we have to consider, the strain and environment, that explains about 43% of variance. Or typically in generally, suppose I tell you, right, this range differs from the 0 to 1, right? The more closer to 1 we can consider, I am getting a very, very good prediction, right? In this case, in the last, what we did, we had 24 number of cases. We took the 3 additional cases and we predicted the value for the 3 new cases, right? Suppose my R square would have, let's say 70% or like 0.70 or 0.80. Then I would have claimed what the numbers I have predicted, I have a confidence of 80%. I can claim the number will be correct with a 80% of confidence, right? So depending on this R square, I can gather and claim as a evidence about the accuracy of my model. Then adjusted R square, right? This R square and the adjusted R square should be closer, right? I build a model or I build an equation for 24 number of cases, right? But in some of the situation, I wanted to deploy this model for, let's say, 100 number of new cases, right? For the purpose of prediction. So if my R square and the adjusted R square are closer, then we can consider, even like suppose I have built my model in for 24 number of cases, but I have deployed the model for 100 number of cases, means 4 times I have scaled up, still I can claim the model may give me a accurate output or a better, my output will be better accurate. Fine. Have you heard something about the coefficient?
Small r.
No, the small r, no, the coefficient. No, it's basically the small r also sometimes it appears as a r square adjusted r square. What I define for this r square adjusted r square, the lower or the smaller case does not change the interpretation. The interpretation remains same. But this coefficient is a very, very association with this linear equation. So have you come across ever the coefficient? Again, I would happily recommend like you go through any of this YouTube reading material or some of the video, depending on your choice. Like if you are a video person, then you can have some of the YouTube video. If you are more into the reading habits, like you can have some now though many resources are available, they explain beautifully how to get a sense of all these things, right? So I would happily recommend that because these are the fundamentals. Okay, so just the two-way ANOVA you have done, right? So your one queries was there basically how to get an interaction, fine. I'm closing this because already you have done that, right? Now I wanted to do a factorial ANOVA. My study is halfway complete now because I know the factors or the variable I have considered for this study. I have taken the appropriate variables, right? But now I wanted to see a interaction also, right? So again, I go to the ANOVA. Under the ANOVA, I go to the factorial ANOVA, right? Under the factorial ANOVA, the same, I choose this, okay, okay, right? Please mind it here. Effect size. Got it? What is your observation now? Can you view my screen?
Yes, sir, we can see the screen.
Now you can see the interaction also.
Yes, sir.
And I have not done nothing because at the moment, because just I have clicked this all effects. That's all, right? And suppose I wanted to do a post hoc test, right? Suppose I wanted to do a post hoc test, I can go to the more results. Please mind it, more results. I expand this more results. Under the more results, I get this post hoc test. Getting me?
Yes, sir.
Post hoc test. If I expand the post hoc test, there is a variety of the options are there, right? So here you see the drop down menu is there. Which of these things I wanted to this thing post hoc test I wanted to, because I have the two factors and I have an interaction label. So I can choose the post hoc test I wanted to perform, right? Let's say this homogeneous group. So that also I can play around depending on as a researcher, right? These are the some of the popular post hoc tests, right? You must have heard of Fisher LST, Ferroni, Sheffy, Tucky HSD, ANOVA equal, right? So what, right, Tucky is a very popular one. Last time also we had done with the Tucky. So if I click the Tucky, what was the interpretation last time? Because if you remember, we had chosen our interaction as a deeper study, right? So what you can make it out? What is the interpretation from this table?
So the dull and restricted streams, dull stream with restricted environments are making the maximum errors.
Maximum or minimum? See, here you can view my table, right? The first row consists of, it is in the descending order, the free and bright. These permutation are producing the minimum error. And the restricted and the dull, they are producing the maximum error. Getting me?
Yes, sir.
So this is the interpretation, right? This will have a quick look for this. A design of experiment also, right?
Sir, can we do the post-hoc test in case of QA ANOVA also?
Which one?
Exactly. Can you do it? It বলো না or দুটো তো একসাথে হয় না কনসাল্ট কর আমি এটাই ওকে দেখতে বলছি
Hello. Hello.
Hello, sir.
Yeah.
Yes, you have done the post hoc test for factorial ANOVA, so we can also do the post hoc test for 2 ANOVA also.
Yeah, you can do that because this is these things you get the tab in the more, right? That comes below. Just let me. That's the fine. Go to the statistics. Go to the ANOVA. Go to the man effects ANOVA. Okay. Variables, errors, environment strain. Okay. Just okay. Right. There, what I had done, I had expanded. Just be mindful. More results. Just below. Did you observe?
Yes, sir.
Yeah. If
Yes.
I expand the more results, I get the post hoc test.
Okay.
Fine. So if I expand the post hoc test, I get a variety of the post hoc test depending on this thing, but you can play around, right? These are the
But
steps.
both case of 2A ANOVA and factorial ANOVA, we have selected all the 3 columns. That is, I mean, variables, environment, strain, as well as error. So what is the difference in, I mean?
No, yeah. So the difference between the factorial ANOVA and the 2A or the man effects ANOVA, because in the man effects ANOVA, I was not getting the interaction. Here, suppose I go to the summary, I was not getting an interaction here.
Okay.
Right. But in my factorial ANOVA, I got an interaction also. Are you getting me?
So the environment into strains, that interaction.
Yeah, that factor interaction.
Okay.
One of the major goal of the ANOVA, your interaction within and interaction between. Means interaction between means between the factors, environment and strain. And within the strain means like this, bright, dull, right? So in this two-way ANOVA, we are not getting an interaction or two-way or your this thing. But in the full factorial ANOVA, you got an interaction also. Right? Suppose I'm going to the factorial ANOVA, right? In man effects, I'm not getting the interaction at all. If I go to the factorial ANOVA, right, here also suppose I choose, right, even currently we are dealing with only the two factors, because there may be a situation we'll be dealing the more factors, right? Even we can define our degree or level of interaction here. Use factorial design to specify the degree of interaction. Are you getting me? Hello?
Yes, sir.
Yeah, so because here currently we are dealing with only the two factors, environment and strain. So by default, it has taken the use the default full factorial design. Suppose we would have a situation where we have more than two factors and you wanted to more deeper interaction, study about the deeper interaction, more level of interaction. So even the Statistica gives you the flexible option to define your degree of interaction. Are you getting me? Here I choose this checkbox, use factorial design to specify the degree. Here I can change, right? I think up to 8 it is supporting, right? But I can write 8 it will generate a very huge matrix, right? So this is the way I can, this is the difference between where factorial ANOVA and man effects ANOVA or two-way ANOVA. Clear now? Hello?
Yes, sir. Yes, sir.
Clear now? Right? Only initially you need to concentrate more in terms of the structuring of your data. Right? So that is one of the very crucial components when you will be doing any of the study. Right?
Sir, actually, we use factorial design to specify degree. When I increase the degree number to 4 or 5, then clicking OK, but it gets back to 2 only.
No, because we have the two factor, right?
Okay.
So you need to apply some basic logic, right? So you have the two, and where the more than two interaction will happen. Got it?
Yes, sir.
Okay. So just have another 13 minutes we are left with. So I will give you a very quick introduction about the design of experiment. One example, right? Right, so you can also start the design of experiment, the RSM and yours.
Sir, excuse me.
Yeah.
We have one more question.
Yeah, please.
So am I audible?
Yeah, I can hear you.
Yes, sir. So when I'm doing the interaction between the two variables, I
Yeah.
cannot see the interaction between them. Means the strain, the environment, the stress strain into environment. That thing I cannot find. I have done this just now also, but I cannot find that
No,
screen
it's
in our.
simple. One sec. You follow my action, and if you are a group of people, one of your fellow colleague also, they can do along with me, right? I'm starting from the scratch. Fine.
Yes, sir.
The data set is in front of me. The data set
Yes,
read.
sir.
I go to the statistics. Under the statistics, I go the ANOVA. I click the ANOVA. I wanted to perform a factorial ANOVA. The reason of performing the factorial ANOVA because I wanted to get an interaction effects. Okay. Fine. I choose the variable. My dependent variable is the errors. My categorical factors are the environment and strain. Okay. Right. Here I factor codes. Okay. If you just check it out, by default, it is selected in your machine also, factor code selected. Then between effects. If I expand the between effects, by
Sir,
default,
factor codes is not saying anything.
you click the factor codes. Click in the factor codes.
Yes, sir.
Right. Suppose it does not, so you do not see in these column, you go to the all. Okay, I am doing the cancellation and again I'm right here. You double click in this blank space. If in your machine it is showing blank space.
Yeah.
Did you get anything pre-restricted kind of thing?
Yeah. When I'm clicking to all, then it is now showing 0 to
Okay.
3 and 1 to 4 or something like that.
Okay. Yeah. So you do the similar kind of the thing with the in the strain also.
Yeah.
After doing this, do you get something like the besides the factor code selected?
Yeah. Now it is showing selected.
Okay.
Yeah.
Now you go to the between effects.
Yeah.
If you expand the between effects, you get a interactive dialog, right? One pop-up has come. Use
Yes.
default full factorial design that has taken by default, right? Because we have the two factors are there. Suppose in a situation if we would have more than two factors, I could have chosen this one checkbox and I could have defined my degree of interaction. But currently
Yes.
we go with the default one. Okay. Right.
Yeah.
Now let's click OK. Let's go for the output. Under this, I go to the all effects. Right? All effects. Now you get?
Yes, sir. Thank you.
Yeah. So now it is showing the environment and strain 16.1 that does not have any effect to the error. Right? Fine. So there was a small miss from your side that you are not choosing the factors, right? Please make sure, right? So whenever you are doing, you also select the factor also. Fine. But anyway, just I will have a very quick overview of design of the experiment. We will be dealing with the same data set, and the reason I will tell you because now you understand this data set much better, right? This rats dot star, right? And to get the feature of the design of experiment, you go to the statistics. Under the statistics, you get something like the DOE, right? DOE. If you expand the DOE, you get these are the various experiments are available in Statistica. 2 KP standard design, 3 factorial design, mixed 2 and 3 level design, central composite non-factorial surface design, mixture design. In addition to that, suppose I expand the advanced feature, then I get more design also, sorry, more experiments also, right? Latin squares, right? Taguchi robust design, mixture design and triangular surface design, design for constrained surface and mixtures, D and AT optimal algorithmic design, D optimal split plot design, D optimal split plot analysis, experimental design builder, full factorial design, so on and so forth, right? Do you know what is the purpose of the design of experiment? What is the broader goal we have when we perform the design of experiment?
To predict the some result from lower runs, we can predict in what should happen in industrial level or
No, industrial level, so that is a domain, right? That is nothing to do this thing. Do you have you gone through like understand the importance of the design of experiment?
yes, sir.
Just don't feel this thing, because just we are interacting. Just like as a motivation, I wanted to share you some of the facts about the design of experiment that will motivate to invest more time, right?
Sir, we can give runs for few parameters, 3 into 3 levels or 4 into 3 levels, and we can from those data we can predict the output for other parameters also.
No, output though we can do in the ANOVA also, right? We were doing in ANOVA also. We were predicting, right? We experienced, right? In ANOVA also, right? We added 3 cases. We could have added, like, due to lack of time, we added 3 cases. We would have 30 cases also, and we would have got a prediction. So why design of experiment?
So is it to predict the more important factors or input variables?
We did all this ANOVA, everything we did, right? One of the objective we achieved, this parameter characterization. Now we can tell out of the 2 factors we have currently, the environment and strain, very well we can tell out of this which of the factors which contributes maximum to the errors committed by the rats. So one of the broader objective of this, DO is parameter characterization. Many of the scenario, because here only we are dealing with the 2 factors with the 2 level and the 3 levels. There may be a situation, right? We have the 35 factors or we have 40 factors, right? And there are the mix of levels are there. Some are 2 levels, some are 3 levels, some are 4 levels. So just imagine how much experiment we have to conduct or we have to carry out, right? Suppose we have the 35 factors, even we have the 2 levels, then 2 to the power 35. Are you getting me? So this much run we have to conduct physically in order to get a maximum the yield what we have the in our mind or in our goal, right? This is a very, very interesting field now, and which is gaining very heavily momentum in the industrial application also. And one of the more, what do you say, the industry, the practice, the design of experiment very widely is the pharmaceutical manufacturing industry. The pharmaceutical manufacturing industry, and in pharmaceutical manufacturing industry, suppose they go undertake any of the study for the drugs research and formulation, there is a recommendation by FDA. FDA means, like, suppose you are manufacturing any of the drugs and you are selling the drugs to the US, right? So you need to follow the FDA guidelines. FDA stands for the Foods and Drug Association of America. Fine. So under the FDA guidelines, the FDA recommends you need to perform the quality by design. The quality by design is nothing, that is basically a statistical approach through design of experiment, right? The chemical industry, they practice very heavily for various tasks of the optimization. And whenever you use the design of experiment, the synonym to the design of experiment is optimization. We are going to optimize our parameter setting. Parameters mean these are my parameters. Environment, strain, right? In order to get maximum yield. In this case, what would be the maximum yield? How I can minimize my error rate, right? Suppose I see the error rate, the minimum error rate is 14 and the maximum error rate is 133. So this is a range of the error are committed out of this 24 experiment on the different combination of the two factors, right? So I do not know, in order to get a real sense of the minimum error, how many experiments I have to conduct, right? How many experiments means more experiments physically, then it costs you more money, more resources, more time, right? So the design of experiment is considered as a virtual research with minimum resources. So virtually, we can establish the statistical significance. Once you establish the statistical significance, then we can take to the wet lab for the real experimentation. But anyway, what I would recommend today is, because this topic is very fast, what I would recommend, similarly, you go to the help and support, go to the help, similar way, you go to the under the industrial statistics, you go to the experimental design. Under the experimental design, we have 11 example has been listed, right? From basic to the very, very advanced, right? And the design of experiment also consists of the two portions. One is like, suppose I go to this data set, I go to DOE, right? Just out of a general sense, which of the experiment will be appropriate for this data set, the rats data set? Whatever you see, the 5 design you see, the most widely applicable experiments, which of the experiment is applicable for the data we have in hand? Is it appropriate for the 2k factorial design? Is it appropriate for 3k factorial design? Is it appropriate for mixed 2 and 3 level design? Is it does this data qualify for the central composite design? Any answer? Does this data we are dealing with, this rats dot star, qualify for central composite design?
Yes, sir.
How? This data is ideal for the mixed 2 and 3 level design, because in environment we have the 2 levels. Under the environment factors we have the 2 levels. Under the strength factors we have 3 levels, right? So this is a mixed 2, and if I choose this design, right, as I was talking about, the design of experiment are in 2 parts. One was the design of experiment. Design of experiment means you need to create a layout, or you need to structure your data. Then you can get into the analyze phase, right? So these are the different kind of the layouts depending on your choice for the experiments, right? As you see, the number of factors, 2 level, 3 level, right? Right. Suppose I create here 4, 1, 7, this thing. So let's see how they. And another is the right, analyze design. At the moment I analyze, suppose I do have the secondary data, like here I do have a secondary data in hand, very well prepared or already prepared, right? So I can go to the analyze design. In analyze design I choose this dependent and the independent factors. I don't have any blocking. You just read the below, the remarks is there. Can you view? Use this option dialog to analyze mixed 2 and 3 level factorial design. Use the central composite design option, but if your design contains more than 3 distinct level per factor. Are you getting me?
Sir, can you please repeat once again?
Yeah. What the caution is, we have chosen which of the experiment we choose for this data set, keeping the structure of the data in mind. We choose mix 2 and 3 level design, right? Because in the environment we have the 2 levels, in the strength we have the 3 levels. So it's a mixed experiments. In one factor I have 2 levels, in another factors I have 3 levels. So we have a mixed factor, mix of 2 and 3 level of the designs. So if I choose this, right, then I get the 2 option, right? One option, because always the design of experiment consists of the 2 parts, design part and the experiment part. Design part consists, but again I would happily recommend you go through the basic level of understanding before performing the design of experiment. You go through a few of the, like what is the design layout, how I can structure a design layout, right? There are lot many things, right, are there, right? So as a researcher, out of your curiosity, you should go into a little details. At least you should have the primary understanding. Else, like if you use Statistica or any other software, right? You click the button, it will get you output, but the interpretation and the result, sometime it could be disaster also, right? So please, I would happily recommend you go through some of the reading material, depending on your choice. Like if you are a video person, you can get into the YouTube. There are many beautiful YouTube videos are there, right? So if I go to the analyze design, in the analyze design, I get this, use this option to analyze mixed 2 and 3 level factorial design. Use the central composite design option if your design contains more than 3 distinct level, right? more than 3, but in our situation, no factor consists more than 3. So this is not a data set which qualify for a central composite design. Are you getting me?
Yes, sir.
Right? So it is basically, this is the reason we have this thing. Another 5 minutes, right? Because I have some other commitment, right? Errors, those I go to this, right? I get this as an output. Just please, I'm doing it again just to get a sense of what I did, right? As usual, I choose the variable of interest, errors as my dependent, and environment and the strain as my independent. Okay. Okay. I got this output window, right? If I go to the quick, right? ANOVA table, we know. The same I get, right? What do you mean by this L plus Q? Dekho, even you do all these, your design of experiment are based on your prediction. And the prediction means broadly all computation goes through the simplex method, right? And all are evolving around this, your regression equation only, because all this you get R square, adjusted R square, right? Residuals, all this stuff, all this vocabulary you get very frequent, not frequent in all the output you get using design of experiment, not limited to Statistica, but any of the software you use, you get all this terminology very frequently. So before getting into the design of experiment, again, I would heavily recommend go through some of the advanced material, get an understanding about what the R denotes to, right? What is the design space, right? What is the blocking, right? What is the adjusted R square and all this stuff. Then your research would be much more intensive, and your research, the time also will be much more easier. Fine. Any of the term you have heard before? Have you heard something like the Pareto chart?
Yes, sir.
Have you heard of? Yeah, if I get a Pareto chart, what you can make it out from this Pareto chart? Here you see, suppose I go to the model. Even here I can describe my interaction. If I was into the quick, if I go to the model, if I see the two-way interaction, right? I wanted to have a two-way interaction, linear to linear, right? Okay. I do not know you have observed the R square before or not, right? The R square changes. The R square changes means your power of prediction also changes, right? And you have something like the prediction and the profiling, right? This is the main component of, this is not only the main component, this is one of the main component of the design of experiment, prediction and the profiling, right? If I go to the prediction and the profiling, there is something called response desirability profiling. If I expand that, right, I put this. What is my objective here? Why I am doing the design of experiment? What is my objective here? Why I am doing design of experiment?
So parameter characterization.
Yeah, parameter characterization. Already we did in ANOVA, right? Then the parameter optimization. So I wanted to investigate out of these two levels and 3 levels in the 2 factors, which of the permutation and the combination gives me the minimum error, right? We investigate what was the minimum error was there, 14, and what was the maximum error was there, 133, right? So I wanted to get some kind of the permutation and combination so I can design my machine, or I design my the clinical trial room in such a way, such a parameter setting, the error will consume minimum error. The rats will consume minimum error, right? So this is one of the very important part of the design of experiment, desirability profiling, right? So once I open it, I get this. This is my target errors. And this is my by default setting. The minimum is 14, right? What we experience in our minimum and maximum. I have C factor set optimum. I wanted to see the optimum value, right? Go to the option. Under the option, different your mathematical computations are there. Quadratic, least squares, negative exponential spline, right? So once you get into more deeper and deeper the study, you'll understand all this thing, right? So you can define your mathematical computation for this optimization. Here I am putting the source spreadsheet with plotted values. In quick see, if you go to the factor grid, minimum 1, maximum 2. This is the factor grid of the environment, because the environment must be the 2 level, right? If I go to the strain, there are 3 levels are there. So this is the range from 1 to 3, and I have split the steps into the 4. Okay, let's go with this specification. This is the desirability specification. What we have defined, the low value is 14, medium value is 73, so on and so forth, the factor levels. What you can make it out from this table? Here I am expecting maximum the desirability is 69%, right? And suppose I set up my environment, my level of environment is restricted, and my level of strain is the dull. I'm getting the 97, the error rate, and I'm getting a desirability value of the 69. I get the very beautiful graphs to support my numerical analysis. This is the contour plot, and this is the spline fit. I can always change this fit, and the color, the background, everything I have in control in Statistica. I can change the property of these graphs, right? If I go here, I go to the option and I change something like, let's say, the quadratic surface, and again I click here, right? So somehow my structure of the graphs will change, right? So this is very a snapshot of the design of experiment. We have exceeded our defined time, right? And you practice with ANOVA, you do some kind of the homework, and maybe in another month we can have a exclusive session on design of experiment.
Sir, please can you arrange the for meeting for the RSM in this month?
RSM is nothing but that is only a graphical representation.
Yes, sir. The character.
Right. So yeah, this like what you see the graph, right? There also you can in the RSM also you get the similar kind of a graphical representation.
Yes, sir. And the characterization of the RSM plot, that is the ridge analysis and all the stuff. Residual analysis. This kind of stuff can.
No. The residual analysis means what do you mean by the residual analysis? And all like before getting into residual analysis is nothing that is observed minus predicted, right? Or typically it is the error. We did some prediction, right?
Yes, sir.
So the observed minus prediction is the residual. So the less residual is there, so our prediction is then more accurate. That is the normal interpretation. Anyway, right. So the response surface methodology we can have. I will see at what how quickly we can set up this. Fine.
Yes, sir. Actually, we have a paper to submit. For this reason, we are in a bit hurry.
No, paper means then you need to make your fundamental clear. If you can tomorrow get me all the interpretation, the glossary of the R square, adjusted R square, right? Because the residual is a result of that prediction only. Are you getting me?
Yes, sir.
So yeah, if you can get me a half an hour presentation, getting all this R square, adjusted R square, right? The residuals, right? So I can do it day after tomorrow. But unless until you make your fundamentals strong, even I carry out a session also, it won't be much of a helpful. It won't have much impact. That is my concern. So you define your timeline, right? If whenever you are ready with all the basic understanding, I just need 15 minutes. You carry me a presentation about the interpretation of R square, adjusted R square, residuals, right? The equation, right? And this equation also what we experience there. As a researcher, there you can do wonders. We saw the grid, right? Because the grid we had split in the four. The four grid we had split our the range from 1 to 2, right? So in the equation you can change it in order to get the predicted value. You can put like the 0.80, like then you get some prediction, right? So this way you can play around. And this is one of the area, the more you can get into, right, to this desirability profiling, the more paper you can publish. Fine. So you let me know, right? as early as like you are ready with all these basic fundamentals, right? After 2 days, then we will have another session, deep session on design of experiment.
Yes, sir.
Fine. You all take in a good spirit, right? And let's see like as how soon we can meet in our next session. Thank you very much for for your time and patience, right? And hope to see you soon, right? Okay. Thank you very much. Signing off for now.